Welcome to the Copper Spice YouTube channel, and thanks for joining us. In this video, we will discuss the different types of inheritance, nested classes, and local classes. Inheritance. Most developers only use single public inheritance, as this is the most common form. The topic of inheritance is a bit broader and should include the study of multiple inheritance and what it means to inherit using protected or private access. Nested classes are pretty common, however local classes are rarely used. We will also talk a bit about common inheritance issues and how to avoid them. The idea of inheritance is fundamental to the definition of object-oriented programming. Before object-oriented design, there was a category of languages referred to as object-based. These languages provided the abstraction of classes, but did not implement any mechanism to express inheritance relationships between those classes. One of the key purposes of inheritance is to describe a common similarity between two classes, where the functionality provided by one class is a superset of the other class. In C++, the inheritance relationship also serves as a mechanism for code reusability. With inheritance, the child class gains the functionality of the parent class, and it can keep this or re-implement any of the functionality to change the behavior of the parent class. This property is the idea of dynamic polymorphism, which is another key element of object-oriented programming.
We will be using the term current class as a way to designate the class we are addressing or talking about. Since all of these terms involve relationships between classes, it is easy to get confused about whose viewpoint we are using to describe a certain feature. The term parent class simply means any class the current class inherits from. The term superclass can be used as a synonym for parent class. A child class is often called a subclass or a derived class. A child class inherits properties from the current class. Since C++ allows multiple inheritance, a child class may inherit from more than one parent. The term base class has several different meanings and is somewhat ambiguous. The normal textbook definition of base class uses it interchangeably with parent class and superclass. Some programmers also use base class to mean a class which is designed to be inherited from. This is a statement about the intended use of a particular class, rather than its relationship to another one. The C++ standard defines yet another meaning for base class by defining the type trait is base of. Class A is considered to be a base of class B if B and A are the same class, or B inherits from A through any number of generations. This means that in the C++ standard definition, a class is considered to be a base class not just of its own children, but also its grandchildren and any other descendants as well as itself. Based on all of these varying definitions, we are going to avoid the term base class and use parent, current, and child. C++ developers are accustomed to using the public, protected, and private access specifiers on their class members. However, many are unaware that all three access specifiers can be used in inheritance as well. The normal specifier is the public keyword. This provides public inheritance, and all of the parent class members will be inherited in the child class exactly as they are in the parent class. As expected, private members in the parent class will not be visible in the child class. This fits the computer science definition of inheritance and matches the behavior of most other object-oriented languages. When the protected keyword is used to create an inheritance relationship, any public members inherited from the parent become protected in the child class. Protected and private members retain their original access. This type of inheritance is of value when you want to inherit from a parent class, but only allow your child classes to be aware of the inheritance relationship. This is not a particularly common use case. Using private inheritance means that all inherited members become private in your current class. This means you can access anything which was protected or public in the parent class, but they are not usable outside your current class. As with protected inheritance, the use cases are pretty limited. Here is some sample code to demonstrate the different types of inheritance. From the viewpoint of the top-level fruit class, it has two child classes which are named orange and pineapple. From the standpoint of the orange class, fruit is a parent, and the pineapple class can be referred to as a sibling class. Since orange inherits from fruit using the public keyword, all three of the data members it inherits will keep their original access specifiers. The pineapple class inherits from fruit using the private keyword. Even though isSeedless is public in the parent class, it will be inherited as a private data member and not be visible outside the pineapple class. The same rules apply to isRound, which is protected in fruit but becomes private in pineapple. Notice that class orange uses the keyword final in the inheritance declaration. This marks the current class so it cannot be used as a parent class. In other words, you cannot inherit from the orange class.
When a class only inherits from one parent, we call it single inheritance. In this example, it is natural that apple and pear would both inherit from class fruit. There is a simple food relationship here, so the inheritance design is not out of the ordinary. On the other hand, why would the QPushButton and QLabel classes both inherit from QWidget? It turns out that in the CopperSpice GUI library, nearly every object which can be drawn on the screen inherits from QWidget. This is an example of where inheritance is not based on a shared implementation. This type of inheritance is based on a common interface, where the parent class is sometimes referred to as an abstract base class. Another example would be a parent class of living spaces. Classes which might inherit from this parent class are things like townhome, house, apartment, hotel, cruise ship, or even a motorhome. It is important to distinguish the inheritance relationship from other times we use the words parent and child. While a push button is an object that can be placed on a window, there is no parent-child inheritance relationship between the push button and the window. We do often say the push button is a child of the window, even though it did not inherit from the window. In this example, we are showing what multiple inheritance looks like. Class Luke inherits from two different classes. This means Luke will inherit the members of both Anakin and Padme. This normally works as you would expect, and all the members of each parent class are inherited by the child. Notice in the line that declares Luke and lists the parent classes, the public keyword appears once for each parent class. The access specifiers are optional, which means forgetting the public is not a compile error. However, if you do leave them off, the default may not be what you expect. Since Luke is a class and therefore has the default access specifier of private, if you forget the public in front of either parent, it will indicate private inheritance. If Luke were a struct, then the default access specifier would be public. Yes, this is a bit confusing, and relying on the default values may result in a real mess. When designing a class which is based on an existing class, there is a choice between inheritance and composition. The idea of composition involves adding a member whose data type is the existing class. This sample code illustrates the two possible strategies. When we redesigned the legacy container classes in CopperSpice, we faced this exact question. We struggled a bit in making our choice and looked at the trade-offs carefully. At the time, this felt like a difficult choice to make. However, now it is clear that we made the better choice by using composition. The typical computer science advice on this subject is to favor composition over inheritance, but it is worth asking why. One of the drawbacks of using inheritance is the potential for undesired implicit conversions. Another reason composition was the better choice was it gave us complete control over the API for our container class. When using inheritance, you generally get the full parent API. However, if you wish to change one of the inherited methods, it can be tricky to do this correctly or in a maintainable way. With the composition approach, you are required to explicitly write wrappers for every method you want to expose, which means changes to the parent class will not affect your API. For example, if they decide to change the API for std vector, the API in CopperSpice is not affected. By using composition, your entire API is implemented in your class rather than being implicitly inherited from an external class. This will make it easier to generate accurate documentation when you are using a tool such as Doxypress.
A nested class is nothing more than a class declared inside another class. In general, nested classes behave just like non-nested classes. However, since the nested class is a member of the outer class, it can be made public, protected, or private as appropriate. In this example, the PyCrust class contains a nested class called cherries. Since cherries is in a private section, it will not be usable by any code outside of PyCrust. One place that nested classes are often used is to hide implementation details. As an example, in the case of iterators, the nested classes will be public, since they form part of the public API of the outer class. One of the reasons that iterators are often implemented as nested classes is due to the syntax. Classes nested within a class template get access to the template parameters. If the iterator were declared outside the container template, it would need its own set of template parameters, and this syntax can get quite complex. When a nested class is declared, it is allowed to access all members of the outer class. The outer class does not automatically gain access to protected or private members of the inner class. For this reason, it is fairly common for the inner class to have a line within it declaring the outer class as a friend. A local class has the syntax of a normal class. However, it is only visible within the function where it is declared. Local classes are not used very much in modern C++. They were somewhat useful in standards prior to C++11 to implement function objects, but this usage has become obsolete with the standardization of lambda expressions. There are several restrictions on what members can be part of a local class. No static data members are allowed, and all methods must be inline and implemented within the body of the class. From within the local class, static variables declared in the outer function are visible. However, local variables are not. To access private data members of the local class in the outer function, the local class needs to declare the function as a friend. In this example, the local class is being used to encapsulate cleanup code in this function. Notice that the only method implemented in the local class is a simple destructor. You must have a variable name for the local class, and in our example, this is dummy name. By declaring this variable, we force the destructor for local class to be run, regardless of how control flow leaves this function. This is a simple example, and given C++ 11 or later, you could do the same sort of technique using a templated class and a lambda. Overall, with current implementations of C++, local classes are not that useful.
Developers disagree on whether multiple inheritance should be used, since there are corner cases, and they usually do not show up right away. In this example, we are defining a class called Meyer-Lemon, which botanically is a cross between a lemon and a mandarin orange. This is a perfect example of when using multiple inheritance matches the objects you are modeling. Notice that both lemon and mandarin orange inherit from the class fruit, using single inheritance. So far, there is nothing out of the ordinary. The problem which comes up is connected to the public data member isSuite. Everything is straightforward in class lemon and class mandarin orange. But what about in class Meyer-Lemon? Which copy of isSuite will this class use? This entire dilemma is referred to as the diamond problem. Fortunately, the code in example 1 will generate a compile error since it is ambiguous. Example 2 is syntactically correct and it will work. So is the code in example 2 the right approach? How would you decide if you should actually use object lemon isSuite or object mandarin orange isSuite? There is another solution which takes away the ambiguity. Adding the keyword virtual to both class lemon and class mandarin orange will not change the behavior of these classes. However, Meyer-Lemon will contain only one version of the members from fruit, so there will only be one copy of isSuite. Virtual inheritance has a number of odd side effects, including which constructors get called and how compiler-generated assignment operators are implemented. If you intend to use virtual inheritance in your design, make sure you understand the trade-offs involved. Multiple inheritance is not the first solution you should reach for or use just because you can. This is a technique to use when a design naturally lends itself to a particular class inheriting from multiple parent classes.
For more information about CopperSpice and the other libraries we've developed, please visit our website at www.copperspice.com.
Thanks for watching. We hope you found the content of value. If you have any questions or feedback, feel free to leave a comment on this video or send us an email.
Please make sure you subscribe to our YouTube channel and come back in a few weeks for our next video.